Okay, so the second factoring process we are going to learn about this week is indicated here at the top. It is called the difference of squares. And if you look at each one of these examples they're starting us off with in the review, you will see that you have two sets of parentheses. The terms are the same, but the sign in the middle is different. So based on what we learned about last week using that FOIL method, we multiply the first and the outer terms, we get x squared minus 4x. We multiply 4 and negative 4, we get a positive 4x and a negative 16. If you notice, the middle terms in this will cancel, negative 4x and positive 4x, and you're left with x squared minus 16. Same idea here in the second one. Multiply 5x and 5x, you get 25x to the second. Multiply 5x and negative 1, you get negative 5x. Multiply 1 times each piece, gives you a positive 5x and a negative 1. Again, you'll notice the middle terms cancel and you are left with 25x squared minus 1. Continuing with the third one, you have 2a times 2a, which is 4a to the second. You have 2a times negative 3b, that's negative 6ab. You have 3b times 2a, that's a positive 6ab. And you have 3b times negative 3b, that would be negative 9b squared. Again, you'll notice the middle terms cancel and you're left with 4a squared minus 9b squared. Now, if you see this little arrow, you'll notice it says this resulting product is called a difference of squares. So a couple key things here that I want to point out. Number one, notice they are a difference. So you must have a minus sign. It must be a subtraction problem. Okay? So that's one thing that must be in the middle for us to use the difference of squares factoring method. Second thing, you will notice the exponents. Every one of the exponents is an even number. So in order to factor these as a square, the exponents must be even numbers. So 2, 4, 6, 8, 10, as long as it's an even number, the exponents can be factored using the difference of squares. And I'm going to come over here for the third thing. The third concept is that you must have coefficients or numbers that are perfect squares. So I'm going to abbreviate the word coefficients, must be perfect squares. And hopefully you remember way back the beginning of the year we talked about square roots, and if you were going to write the list of perfect squares, you would go through and think 1 squared is 1, 2 squared, 2 times 2 is 4, 3 squared is 9, 4 squared 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, and 12 squared is 144. So I would expect that you know that each one of these numbers is a perfect square. What that means is you could take the square root of that number and it would result in an integer. So the square root of 100 would be 10. The square root of 36 would be 6. To factor a difference of squares, you're going to use the following rule. You are going to set up 2 parentheses. And if you have exponents, you are going to split them in half. So I have a squared. That's going to turn into 1a and 1a. B squared. If you split that in half, that turns into b and b. And every single time, in order to get these middle terms to cancel out, you will need to keep a plus and a minus sign in your answer. So, as you move through these questions, once you get the hang of it, the difference of squares is really the easiest method as soon as you recognize that you have a difference of squares. So if I look at number 1 here, I have a squared minus 4. If you go through your checklist, you see we have a minus sign, that's good. The exponents have to be even. We have a 2, that's an even number. And the coefficients, the numbers, have to be a perfect square. Well, 4 is in our list of perfect squares. So we are going to set up 2 parentheses. The first term, a squared, will be factored into a and a. You will always use a plus and a minus sign, and then you will take the square root of 4, which is 2, and that number would be placed at the end of each parenthesis. What you should notice is if you were to FOIL this answer back and multiply a times a times negative 2, 2 times a, and 2 times negative 2, that you would get a squared minus 4 as the result. So again, you are breaking these expressions down into a product. If you look at number 3, 81 is a perfect square. It's in our list. The square root of 81 is 9. So that number will go first in each parenthesis. X squared, well, it's even, so we split it in half, which would leave us with 1x in each one of our parentheses. In number 5, I hope something jumps out at you. And if you look at number 5, you will notice the sign here is addition. It must be subtraction. So if there is a plus sign here, it cannot be factored. We will write that this is prime or cannot be factored. Okay, now number 7, continuing along, you see 9 and 100. 9 again is a perfect square. The square root of 9 is 3. So 3, and split the b squared in half. 3b will go first in each one of our parentheses. Then as you take the square root of 100, that would be 10. So 10 will go last in each one of our parentheses. So I'm hoping you're noticing that you're taking the square root of each one of these terms. Now for number 9, the square root of 16 is 4. Split the exponent in half, that is a. You have another 4a, and then the square root of 121 is 11. So 11 will go last in each parenthesis. As we continue with number 11, you will notice that you have 4 and 25. They are, again, perfect squares. So the square root of 4 is 2, and split that h in half, you would have 2h. Again, always using a plus and a minus sign. The square root of 25 is 5. Split your g in half, you will have 5g. In number 13, you have x squared, y squared. You will split those in half and get xy. The square root of 1 is 1, so xy plus 1 and xy minus 1. Continuing through and onto the back page, you have a couple questions here. If you look at 15, you have 4c squared minus 5d squared. Now the exponents here are even, and 4 is a perfect square. However, 5 is not a perfect square. So, since this is not a perfect square, this is something that we cannot factor any further. So that keyword we've talked about, this answer will be prime. 17 and 19, you will notice that the exponents are a little bit higher, but still even numbers. So we split those exponents in half. You will have k to the third and k to the third, plus 4 and minus 4, as the square root of 16 is 4. Continuing along with number 19, the square root of 121 is 11. R to the 6th, we split that in half, we will get r to the third, plus 1, and 11 r to the third minus 1. I got the 1 from taking the square root of 1. in the second term. I hope this makes sense as you're working through 20 all the way back up to number 2. I will tell you on that side, there are not any answers that are prime. You should be able to factor all of them. Please be careful as you go through and make sure that you keep the terms in order. So for example, if the number is first, like in number 6 here, then you still need to have a number first in your answer. So for example, this would be 1 plus 7y and 1 minus 7y. As always, if you have questions, please let me know.